Okay, let's continue looking at the number of elements in two sets. Let me get another set here, another Venn diagram I mean. Suppose I'm told that there are two sets, P and U. The number of elements in P is equal to, in this case, 1, 2, 3, 4, 5, 6. Number of elements in P is 6. It's just 6. Number of elements in P is 6. The number of elements in C is 1, 2, 3, 4, 5 of them. And the number of elements in both is X. Pretend as if I didn't know this was the case. How would I deal with this? Suppose now I'm told use a Venn diagram to represent the situation here. Alright, let me make this a little bigger. Alright, use a Venn diagram to represent this situation here and calculate X. I have P here. I know there are some in both, and I have C here. Alright, now the number in P is 6. 6. Now if you write this 6 and you don't make any change to the 6, then you would be wrong, because what happened? In both is X, and this is saying there are 6 plus X in P. This is saying there are 6 in P. Yet this diagram would be saying the number in P is 6 plus X. Suppose X is 1. Then you would be saying there is 6 plus 1, which is 7 elements in P. Suppose X was 2. You would be saying there are 8 elements in P. But the fact is, the statement says there are 6. So what should you do about this? What you're going to have to do is say 6 minus, you're going to have to subtract here. You're going to have to say 6 minus X. Because the truth is, 6 minus X plus X is 0, because negative X plus X is 0. Alright, so in this case you would have 6 minus X plus X. 6 minus X in P only, plus X in both. Then in C there are 5. You cannot put just 5, because X is also in C. You don't care whether it is in P as well. As long as it is in C, it is in C. So this statement would be saying there are 5 plus X elements in C. But that would be wrong, because the statement says there are only 5 in C. So you'd have to say 5 minus X is here, plus X in the intersection. Alright? Now the statement would also say the number in both P and C are P only and C only, which means the union. It's saying one alone or the other alone or in both. The number in the union is, how much you have? 6, 7, 8. There are 8. What you would do, even without this formula, you could say the number 6 minus X plus the X in the middle there, plus the 5 minus X is equal to 8. So you'll say negative X plus X, this is gone. Alright, negative X plus X is 0. 6 and 5 is 11. So this 6 and this 5 is 11, minus X is equal to 8. 11 minus what gives you 8? Or if you want, you could add x to both sides and subtract 8 from both sides. So 11 is equal to, when you have negative x and add it to itself, you're going to have 8 plus x, because negative x plus itself, let me just go through this. My, what a big eraser, it erased everything. Let's go through the steps here. So 6 plus 5 minus x is equal to 8. What you want are numbers only on one side. Let's put the 6 and 5 together here. 6 and 5, 11 minus x is equal to 8. Put the x on one side only and the numbers on the other side only. To get rid of x here, you plus x. So negative x plus itself, and it's gone. You have 11 left is equal to 8, but if you add x to the left, it will get heavy, get too heavy compared to the right, so you have to balance it back by adding x to the right as well. So plus x. Then you subtract 8. To get rid of 8, you subtract 8 from this side, and you subtract 8 from here. So 11 minus 8 is equal to x. So x is equal to 11 minus 8 is 3, and you have 3 here. All right, now let us look at using this formula and see if we get back the 3. Here we have number in the union is 8 is equal to number in one of them alone. Number in P alone is 6 plus, number in P, not alone. Number in P is 6. Some of them are in P alone, some of them are in other things too, but once it's in P, there are 6 of them in P according to the statement. The number in C is 5 minus the intersection of x. So what do? You say 8 is equal to 6 and 5, 11 minus x. What you could do here, let's not move the x. You subtract 11 to get rid of the numbers. You don't want any numbers mixed up with the x. So here you say 11 minus x, but how you get rid of the 11? You subtract 11. 11 minus 11 is 0. So on the right you will have negative x alone. But if you subtract 11 from the right, then the right hand side gets a bit light compared to the left. You need to subtract 11 from the left hand side as well. So it's 8 minus 11. What is 8 minus 11? It's negative 3. Negative 3 is negative x. Therefore, positive 3 is equal to positive x. So x is equal to 3 again. Alright? But what I did here was just an algebra. I have a separate section on algebra. Right? You should practice your solving simple equations, linear equations, and so on. But this gives you the general idea. The formula says the number in P union C is a number in P plus the number in C minus the number in both P and C, because when you count the number in P, you will also count those in C too that are in both P and C, and then you go over to C and count them. You're going to also count the number in P as well, because some of them are in C and P. So you subtract that double counting that you did. Alright? So you minus the intersection. And then, if you're asked a question, the number in P is 6, the number in C is 5, and the number in both is x. and everybody come together is 8. The union is 8. Then you have x in the middle here, both. When you write your 6 here, you cannot just leave the 6 like that. You have to say 6 minus x, because if you don't say 6 minus x, you would be saying the number in P is 6 plus x, which would be wrong, because it should be 6. Now, when you put the minus x here, then the number in P is 6 minus x plus x, and you know that the minus x plus x is 0, so whatever x is, the minus x plus x is 0, and the 6 is left. Alright, so that is number of elements in intersection of two sets. We'll be doing several examples in the future, so you can follow that.